It has been 2 years since NASA's James Webb Telescope gave us a stunning first look at the depths of our universe. The $10 billion telescope is the largest and most powerful in space. It captured these images.
After the James Webb Telescope revealed what NASA was concealing on Mercury, the United States promptly shut it down. This little planet is anything but normal as it comes close to our enormous Sunday. Its fiery terrain is dotted with surprising gems, like diamonds, that glitter. However, beneath the shimmer is an odd and massive core that defies all prior understanding in science. What undiscovered tales lie behind these astounding discoveries? Join us as we reveal the discoveries that have the potential to completely change our understanding of the planets. Mercury may appear little when compared to the Sun, but don't be deceived by its size. Below that scalding surface is a treasure mine of amazing mysteries. Recently, a startling discovery was made by earthly probes. Diamonds are widely scattered over Mercury's surface. On one of our solar system's hottest worlds, diamonds. And that's only a cursory examination. As we dig farther, we discover that Mercury has a strange and remarkably enormous core. These findings raise an important question: what distinguishes Mercury from its planetary siblings, and what other mysterious stories may it be hiding? Since Mariner 10 was the first spacecraft to reach Mercury, it was a pioneer. It returned the first close-up images, revealing a world resembling our moon in terms of craters and odd ridges. This mission disproved long-held beliefs about Mercury's composition by revealing that the planet has a rough surface, an unexpectedly strong magnetic field, and a larger core than previously believed. However, that wasn't the most unexpected aspect. 31 years later, the Messenger mission began, revolutionizing our knowledge of Mercury. Messenger, in contrast to Mariner 10, was built to circle Mercury, enabling it to conduct extensive, long-term research on the planet. It took roughly 200,000 pictures, expanding our understanding of this fascinating planet and revealing hitherto unseen areas of Mercury. A fascinating discovery made by the Messenger mission was the observation of very high calcium and magnesium concentrations on Mercury's darker side. Scientists became interested in the possible natural mechanisms that produced these elements at such high concentrations as a result. It was also discovered that, in contrast to other planets in our solar system, Mercury's magnetic field was surprisingly greater in its northern parts. These discoveries made scientists recognize that their preconceived notions about Mercury's interior composition and evolution were greatly off. On Earth, the flow of molten iron within the core is often responsible for creating magnetic fields. However, Mercury exhibits a distinct kind of magnetic activity due to its distinct interior structure. What else distinguishes the scenery of Mercury? The planet is characterized by harsh weather in addition to its craters and ridges. Mercury's surface may get as hot as 806 degrees Fahrenheit during the day, which is hot enough to melt lead. However, the temperature drops significantly to around -292 degrees Fahrenheit at night. Mercury's tiny atmosphere makes little contribution to heat retention or temperature regulation, which results in this extreme temperature variation. But there are other unexpected aspects of Mercury besides its intense heat. Some surprising traits on its surface have been revealed by more recent investigations. Data from Messenger in 2012 revealed evidence of historical explosive eruptions as well as signals of volcanic activity. The old theory that Mercury was geologically dormant was called into question by this discovery. Then, in 2020, scientists made an even more fascinating discovery. Parts of Mercury's permanently shadowed polar craters were revealed to contain water ice. Despite Mercury's near proximity to the Sun, these places remain sufficiently cold to maintain frozen water. They are always protected from the Sun. There were increasing doubts regarding Mercury's capacity to maintain primitive life forms because of the ice. Could life exist in these frozen areas on Mercury, akin to those of Earth's most hostile environments? This query raises intriguing prospects for our knowledge of the possible survival of life on various planetary environments. But the narrative doesn't end there. Together with the Japan Aerospace Exploration Agency, the European Space Agency launched the Bepi-Colombo spacecraft towards Mercury in 2018. By 2025, it is expected to reach Mercury. As it arrives, Bepi-Colombo will begin gathering comprehensive data about the planet, including its surface composition and geological past. Interestingly, Mercury has some water ice and a strong magnetic field despite being so near to the Sun. What may surprise you even more is that Mercury has a day that is longer than its year. Typically, when we think about planets, we picture them around the Sun once a year and rotating on their axis once every day. Mercury, though, is not like that. A day is actually longer than a year on this little, sweltering planet. Come with me as we investigate Mercury, where a day is longer than a year. A symphony of sun and shadow. Mercury's year is far shorter than ours. It only takes 88 Earth days for it to complete one orbit around the Sun. On the other hand, a whole day on Mercury, or a full rotation on its axis, takes around 176 Earth days. Therefore, on Mercury, a year is just half as long as a day. This has some rather peculiar results. The Sun rises and gradually grows larger as it travels across the sky, as seen from Mercury. However, an odd occurrence would occur. The Sun would seem to come to a stop, retrace its steps, and then carry on. Because Mercury spins so slowly in relation to how quickly it circles the Sun, it causes this peculiar movement. The oddest part, though, is not that. First of all, why does Mercury revolve so slowly? Tidal locking holds the key to the solution. The gravitational pull of the Sun has been steadily slowing Mercury's rotation for billions of years. Mercury is in a 3:2 spin orbit resonance, in contrast to the Moon, which is completely locked to Earth. This indicates that Mercury spins 3 times for every 2 orbits around the Sun. Mercury experiences harsh circumstances as a result of these peculiar orbiting and spinning patterns, particularly given its peculiar day-night cycle. Mercury's solar-facing side experiences months of intense heat, while its solar escape side has equally lengthy periods of icy darkness. Some of the solar system's most extreme temperature swings result from this. It's crucial to remember that Mercury doesn't actually have what we would consider a proper atmosphere while discussing it. Rather, it possesses a very thin layer known as the exosphere. Due to its extreme sparsity, this layer continually evaporates into space and is only sporadically replenished by solar wind, radioactive material disintegration, and collisions from small space pebbles. Unexpected information on Mercury's exosphere has been revealed by recent research. 2020 data from the Messenger spacecraft showed that scientists had previously underestimated the amount of water vapor in Mercury's exosphere. This water vapor is probably created when oxygen in the rocks on Mercury's surface combines with hydrogen from the solar wind. The speed at which Mercury circles the Sun, in contrast to its comparatively sluggish revolution on its axis, is another amazing feature of the planet. Its magnetic characteristics are affected by this peculiar mix. Scientists were surprised to learn that Mercury possesses a strong magnetic field despite its modest size and sluggish rotation. Subsequent research indicates that Mercury's specific spin and orbit combine with special internal motions within its liquid metallic core to produce this magnetic field. Even so, it is significant that this magnetic field is less than Earth's. Mercury's surface is shielded from the strong solar wind by it. Mercury's already thin atmosphere would be further thinned by the solar wind in the absence of this screen. Mercury spins slowly, which makes for some fascinating scenarios when paired with its rapid orbit around the Sun. Mercury has areas on its surface known as hot poles, where the Sun appears to pause in the sky for a period of time, resulting in extraordinarily heated conditions there. However, due to persistent darkness in the regions close to Mercury's poles, ice may survive despite the planet's close proximity to the Sun. Mercury's distinct spin and orbit around the Sun are the reason of this. Even though the rest of the globe is scorching hot, the craters in these dark regions remain very cold because they never get sunlight. Researchers are also questioning whether there are any additional materials, possibly even organic ones, hiding in these frigid areas. Mercury's slow rotation and quick orbit have an impact on our understanding of the planet. It is a difficult target for spacecraft because of its rapid orbit around the Sun. Spacecraft must employ sophisticated navigational procedures, including many flybys of Venus and Mercury, in order to slow down sufficiently to enter orbit around Mercury. These flybys are now being used by the Bepi-Colombo mission to modify its trajectory and speed. After 9 flybys, Bepi-Colombo, which was launched in 2018, is anticipated to begin circling Mercury by 2025. Once there, Mercury's peculiar day-night cycle will present difficulties that must be overcome by careful control over its power and temperature in order for it to live. The mysteries of Mercury begin to surface as one digs deeper. An odyssey into the heart of the planet, however, there are other difficulties. According to recent research, Mercury may have formerly spun more quickly but gradually slowed down as a result of the Sun's gravity and potential impacts with other celestial bodies. This discovery not only sheds further light on Mercury's past, but also on the processes that shape the planets in our solar system as they evolve. New inquiries concerning the inside and surface of Mercury arise as we learn more. Its core, which appears somewhat fluid in spite of the frigid temperatures, and the way its peculiar orbit influences its geological aspects, pique the interest of scientists. The scientific community is always intrigued by the new findings and what more they may uncover about Mercury. Mercury continues to astound scientists and cast doubt on our understanding of the formation and evolution of planets. What additional mysteries may be concealed beneath the surface of this little planet full with craters? Mercury is the smallest planet in our solar system, yet scientists are still baffled by a number of its secrets. Despite its little size, it has several rather strange characteristics. Mercury's enormous core is among its most intriguing features. According to a research headed by planetary scientist Dr. Nancy Chabot, Mercury's core comprises around 85% of the planet's entire volume. In comparison, just 15% of Earth's bulk is comprised of its core. This begs the important question, why is Mercury's core so massive? One widely held belief is that Mercury was once considerably larger, but that, during a massive collision early in the solar system's history, it lost much of its outer layers. This notion was put out by Dr. Eric Asfog and is referred to as the hit-and-run scenario. He proposed that Mercury may have been struck by a massive object that stripped away its outer layers and left behind the iron-rich core that is seen today. Mercury continues to amaze people, nevertheless. Scientists were surprised to find a magnetic field on this tiny, slowly spinning planet. With a magnetic field that is around 1% as powerful as Earth's, Mercury possesses a worldwide magnetic field, unlike Venus and Mars. Scientists were baffled by this finding, which NASA's Messenger spacecraft made. Then there was still another turn. Mercury has an uneven magnetic field, according to research by Dr. Katherine Johnson and her colleagues. In actuality, the planet's radius is displaced by around 20%. Variations in Mercury's crust may be related to this odd change, since they may have an impact on the planet's core's ability to release heat. And if that wasn't enough, scientists discovered in 2020 that volatile substances like sulfur, potassium, and sodium are present on Mercury's surface. This further enigmatizes a planet that is already complicated, provoking further inquiries and research as researchers attempt to solve Mercury's numerous puzzles. However, these findings just hint to what Mercury may still be concealing. What more may this little planet disclose? It is remarkable to see some compounds on a planet thus near to the Sun that normally vaporize at high temperatures. An intriguing concept has been proposed by Dr. Patrick Peplowski of the Johns Hopkins Applied Physics Laboratory. He speculates that these materials, which transform into gas very fast, may have been carried to Mercury by comets or asteroids much later on in the formation of the planet. The discovery that water ice exists inside permanently shadowed craters at Mercury's poles is among the planet's most thrilling discoveries. As we previously noted, Dr. Nancy Chabot was instrumental in this research. Because the craters are too cold to receive any heat from the sun, these icy areas remain frozen. The finding of biological stuff in these frozen areas is even more intriguing. Researchers have discovered dark regions that could hold complex carbon molecules, which are comparable to those that may have contributed to the origin of life on Earth. Is it possible that Mercury, with its harsh environment, might provide us with information on how life first emerged in our solar system? When it comes to its geological activities, Mercury has other surprises. Scientists believed Mercury to be geologically dormant for a very long period. However, fresh data from the Messenger spacecraft suggested recent volcanic activity. On the surface of Mercury, what appear to be tiny, lustrous volcanic vents were discovered by Dr. David Rothery of the Open University in the UK. These structures, known as hollows, provide insight into the planet's continuing geological processes. Next, the landscape of Mercury is a maze of mystery and disorder. Mercury's chaotic heart, the chaotic landscape, a vast, disorganized region of hills and valleys close to the southern pole, is one of the planet's most perplexing geological characteristics. This area, roughly the size of Texas, was found during the 1970s Mariner 10 mission. According to Dr. Thomas Waters of the Smithsonian Institution, this terrain may have been formed by large earthquakes that were triggered by the Sun's gravitational pull when Mercury's orbit altered. That's not all, though. We now have a better knowledge of Mercury's internal structure thanks to recent research. Mercury's interior composition was examined by Dr. Amir Khan of the University of Zurich using information from the Messenger mission. According to his findings, Mercury has a solid inner core and a liquid outer core, just like Earth. Mercury's inner core, however, is far bigger in comparison, which might account for some of the planet's peculiar magnetic characteristics. These unexpected characteristics of Mercury force us to reconsider the formation and evolution of planets. They serve as a reminder that there are still a ton of undiscovered things, even in our own backyard, the immensity of space. We can only speculate as to what additional fascinating information could be concealed beneath Mercury's surface as we eagerly await more investigations and discoveries. Mercury's secrets are just as fascinating as anything that can be seen on its surface, as evidenced by recent missions and research. The inside structure of Mercury is really amazing. Mercury has a mainly liquid core with a solid center, in contrast to Earth, which has a solid inner core encircled by a liquid outer core. NASA's Messenger mission, which investigated Mercury's gravity to find out more about the planet's interior, verified this. About half of Mercury's total core is made up of its solid center, which is around 1,260 miles, 2,000 kilometers, broad. Only 20% of the Earth's core is composed of solid matter. This distinction in composition and size is significant since it contributes to the formation of Mercury's magnetic field. Mercury is a tiny planet, yet despite this, it nevertheless has a rather powerful magnetic field compared to Earth. The mantle layer is remarkably thin, sitting just above Mercury's core. Compared to Earth's mantle, which is estimated to be 1,800 miles, 2,900 kilometers, deep, scientists now believe that this mantle is just 260 miles, 420 kilometers, thick. The distribution of heat on Mercury and its geological activity are influenced by this thin mantle. However, Mercury is more complex than first appears. The Messenger mission found evidence of historical volcanic activity on Mercury in 2012. It's possible that Mercury contained more volatile compounds than previously believed since the probe discovered unusual, shallow depressions known as hollows, which were created when volatile molecules near the surface evaporated. Then, in 2020, researchers discovered evidence of a sizable magma reservoir that had formerly existed beneath Mercury's surface using information from Messenger. The planet's surface and deeper layers were probably significantly shaped by this ancient sea of magma. Mercury's surface features large, flat plains, particularly in the northern hemisphere, which can be explained by this magma sea. Known as the Northern Volcanic Plains, these regions were probably formed early in Mercury's history by massive lava flows. Mercury surprised us again, though. Researchers found even more mysteries under Mercury's stony surface in 2022, demonstrating to us that there are still a lot of untold stories about this planet. Researchers examining MESSENGER mission data have discovered indications of nitrogen subterranean on Mercury. This nitrogen may represent remnants of a dense, prehistoric atmosphere driven underground by the extreme heat and continuous solar radiation of the planet. This finding raises intriguing queries concerning Mercury's history. Was it formerly considerably thicker in atmosphere? What does this indicate about the circumstances that existed on the planet in the past, and is it possible that life was maintained there? In the shadowy craters near Mercury's poles is aqueous ice as well. This ice is on the surface, yet the intense cold in these shaded places keeps it shielded from the sun's rays. According to recent studies, part of this ice may be quite recent, having most likely been delivered in the last few tens of millions of years by comets or asteroids. There are indications now that Mercury is still evolving, revealing geological mysteries, but that's not all. It's also believed that biological stuff, probably carried there by the same space impacts, is present in these dark areas within the polar craters. This organic substance presents a unique chance to examine the distribution of organic molecules in the inner solar system, since it is less stable than water ice. The underlying characteristics of Mercury also reveal information about its geological past. Mercury does not exhibit plate tectonics as Earth does, but it does exhibit distinct evidence of contracting as it cooled. The many thrust faults that crisscross its surface, where certain sections of the crust are forced upward over others to occasionally reach heights of several kilometers, are indicative of this. These flaws provide important insights on Mercury's interior composition and geological past. The fascinating part comes next. Additional investigation into these faults raises the possibility that Mercury is still geologically active. A 2019 study discovered evidence of grabens, which are tiny valleys formed by crustal straining close to some of the planet's biggest faults. Given their apparent youth, these characteristics suggest that Mercury's crust is currently undergoing change. Moreover, Mercury has a magnetic field that is distinct from Earth's. Mercury's magnetic field most likely originates from a different mechanism than that of Earth, which raises more questions regarding how magnetic fields are created on other planets. Earth's magnetic field is created by molten iron flowing in its outer core. The theory that Mercury's magnetic field is created by liquid metal circling the planet's solid inner core is now being investigated by scientists. This mechanism suggests that Mercury has an incredibly active and complicated interior, akin to what we observe in other planets and stars. However, there's more. Subterranean Mercury is a topic of great interest to scientists. It is their belief that the planet's crust may include numerous fractures and cracks. These could make it possible for heat and possibly even liquids to travel between the planet's layers. This theory is especially fascinating since it implies that Mercury, which was previously believed to be geologically dead, may yet have some active processes occurring within. Despite the fact that Mercury's surface is now dry and arid, some scientists believe that there may be water pockets concealed far below the crust. If these reservoirs of water are real, they may represent the remains of a period when Mercury experienced a more mild environment, or the planet's internal heat may be keeping the water liquid. This theory is consistent with discoveries made on moons like Europa and Enceladus, which conceal seas behind dense ice sheets, raising questions about potential locations for life in our solar system. The discovery of water on Mercury may inspire more investigation into the planet's historical ecology and capacity to sustain the chemical reactions necessary for life. Should water be discovered, it might provide crucial information about the planet's geological past and pose fresh queries regarding the chemical processes taking place under the surface. But Mercury isn't the only factor in this. Scientists can learn more about the formation process of rocky planets like Earth by investigating its innards. Comprehending the volcanic activity, Earth's core composition, and Mercury's geological past are essential to constructing a comprehensive picture of the solar system's planet's evolutionary history. Each new finding about Mercury broadens our understanding and provides new perspectives on the early solar system. For example, Researching gases and other materials buried beneath Mercury's surface may provide important insights on the planet's prehistoric atmosphere and environmental circumstances that prevailed billions of years ago. There is increasing anticipation for upcoming expeditions to Mercury. These missions will investigate Mercury's surface and its undiscovered depths using cutting-edge technologies. We want to discover more about this enigmatic planet and its role in the greater scheme of our solar system with every expedition. Mercury is tiny and near the Sun, but it still has a lot of secrets. Not only might exploring its depths help us learn more about Mercury, but it may also hold the key to understanding the formation and evolution of our solar system. Studying Mercury is crucial to the area of planetary research and exploration because it provides a rare chance to comprehend how the Sun affects the planets. What findings may put our existing knowledge of the solar system to the test? Comment, like, and subscribe for more.